Okay, so everybody ready? Okay, so this is going to be a little bit different. I'm going to assign a program to you, but I'm not going to explain it very much, unlike the first program that we did where we kind of walked through it. So now this is in the wrong place. There we go. So this is actually a program out of the book. It's a programming exercise out of the book. But I am going to explain it, but I'm not going to walk you through it. And so I want you to remember a couple of things. I know that some of you are a little bit more advanced, which is, I'm wondering why you're in this class. But don't use if-else statements, elif statements. Don't use conditions for this. You may be, yeah, I know. You may be tempted to do that, although it's not too bad for this one. But it's at the end of chapter 2. It's on page, what page is it on? I can't see my book is the problem. I gotta move this over here. So what page is this? I still can't see because it's not wide enough. There we go. 77. So it's a program development program. It's a program development problem. And we're gonna do the, oh, am I recording? Yes, I am. No, I'm not. Am I?
You are.
I am. Yes, I am. So we're going to do D3 on page 77 with modifications. Okay, so we're going to change this a little bit because the book is a couple of years old and well, it's using kind of older information. So what the program is supposed to do is it's supposed to, here, I'll show you because I kind of created it. But I have to be careful what I show you because I'm not showing you code because everybody will pause the video on code. So let me do this. Python programs, all you guys can see is my whiteboard. Okay, so what's it called? What did I call it? Oops. I opened it the wrong way. So let me get this running. And now I can share my window with you. So the thing I tell you not to do. Which one is it? That's not it. That's it. Okay, so here's the program. I ran it. And basically what this program is going to do is it's going to tell us how many images I can put on a flash drive given a certain size. And again, it's by the way, there's a lot of information on the internet about how many pictures you can put on a flash drive or a memory card, depending on the different formats. So this program is going to kind of do that. If you go to like SanDisk, they have a whole section where they say, on average, you can fit this many pictures. So basically, we have one input. And that input is going to be how big the flash drive is in gigabytes. And so if I type in a number here, like, I have to click on it, like 8. So let's say that it's 8 gigabytes. My output is going to be, oh, I wanted to double space that, yeah. My output is going to tell me 4 things, and I should probably format that. So this is not the greatest. I should probably format that to not say 0.0. Because why? Because it's never going to give me a decimal answer. Okay. So basically it's saying that it's giving me four different formats. So GIF, JPEG, PNG, and TIFF. And it's telling me approximately how many pictures I can fit onto an 8 gig memory card. And this brings me back to the days when digital cameras first came out and you could fit like 5 pictures on a memory stick. Now, because we had megabytes of storage instead of gigabytes, and now we have so much storage, like I can get 3,215-ish pictures on a 8 gigabyte memory card, and that's crazy. But so that's basically how it works. So hopefully you all can see that. I'll stop sharing because we don't need to do it again. And let's talk about, let me close this and that, and let's talk about how this program is supposed to work. So what's screen 1 and what's screen 2? It changed for some reason. So can you see the book? Can you see the book? Yes, okay, thank you. So basically we're going to create a program that determines how many images can be stored on a given USB flash drive. The size of the USB drive is to be entered by the user in gigabytes. The number of images can be stored must be calculated for GIF, JPEG, PNG, and TIFF image file formats. The program output should be formatted as given. And I forgot to do a double space between my input and my output, which we should have because that spreads things out. And by the way, I did not do a welcome section to my program. So you didn't see the welcome to the picture calculator program. So make sure that you have a welcome. Now here's the tricky bit. It's all relatively straightforward, but except for the tricky bit. So this bit, oh, I'm highlighting stuff. I guess that's okay. This bit's a little bit tricky. So the ultimate file size of a given image depends not only on the image format used, but also on the image itself. And that has to do with how many megapixels the camera has. So most of us have phones, right? And I don't know, what do you guys have as far as megapixels on your phone? You know what? I don't actually even know what my phone has because I have actual cameras. And I hardly take pictures. Does anybody know how many megapixels their camera on their phone is? No, nobody knows.
Yeah.
It's a computer science class. I figured somebody would know. Nobody? How many people are there? Okay, 12, 12, 12. So let's use 12. One of my cameras is 12 megapixels. So let's use 12 megapixels. And by the way, I used 8 as in my program. I think yours is 8. Okay. So you have a 1 megapixel camera? You know what, Patrick? That is the first camera I ever saw. And my neighbor at the time across the street had one. And it was this, you have one, you know what it looks like. It's a big square thing. Yeah, it's a square looking thing. And you actually put a 3.5-inch floppy disk in it. And it takes 640 by 480 JPEGs. And you can fit like 8. on a floppy disk, I think. He hasn't used it in such a long time. You can't fit very many pictures. But I remember my neighbor coming out, and he was we talked a lot. And he goes, "Look what I got. I got this digital camera." And I remember looking at it. It was that typical Sony color, that grayish blue, plasticky thing, chromy, bluish. And by the way, all my cameras are Sony. All my digital cameras are Sony cameras. So yeah, but that was really kind of cool. But so I do remember that camera. Yeah, there you go. So we have 8 and 12 megapixel cameras. So what does that mean? It means that when you take a picture, it has a certain resolution. And that resolution has to do with how big the file size is going to be. Because we store images, we capture individual pixels. And so if you look at the book, it says it not only depends on the image format used, but also the image itself. So, for instance, JPEGs allow the user to select a degree of compression for the image quality desired. So that means it compresses the file and makes it smaller. For this program, we assume the image compression ratio is given below, and that's not. It's going to change just for JPEGs. Also assume that all images have a resolution of 800 by 600 pixels, which nobody has anymore. I think that's equivalent to a 2 megapixel camera or something like that. Nobody uses that anymore. So we're going to use a different resolution for this program. And you can pick 8 or here, let me just do this. Let me look up the resolution for a 12 megapixel camera. And include this in your program intro, whether you're doing 12 or 8. So a 12 megapixel image is 4,000 by 3,000. Okay, so that's a number that you need to remember if you want to create this program using 12 megapixel resolution. And if we knew how to do elif statements, we could actually have that be user input. But actually, we'd have to do a list because we'd have them enter how many megapixels their camera had, and then we would figure out the resolution. We'd have a list, and then we'd pick one. But we're not going to do it that way. We're just going to pick it and use it in our calculations. It's going to be hardwired into the program, basically. So if you're going to do 12, it's 4 by 3, 4,000 by 3,000. If you want to do 8, it's going to be 2688 by 1520. Oh, that's a 4 megapixel. Wrong. It's not. Here we go. Got it. Okay, does everybody see that? That's 8 megapixels. 3840 by 2160. So do either one. Okay? By the way, 8 megapixels is 4K resolution. Okay? And 12 obviously is higher, and you can get 16 and 24 and 36, and they're like 50 megapixel cameras now. So you can go way beyond that. But I think typically on our phones we have 8 or 12. So that's what we should use. And that's going to be part of the calculation that we do. Okay. Now we have to look at both of these. Okay, so yours is 5 megapixels. By the way, I also have a 5 megapixel camera, but that's kind of older. So let's do 8 or 12. Okay, 5 is less than 4K. And I think that in the future, we're going to want at least 8 megapixels because we're going to maybe, because I don't know what we do with pictures anymore, but we used to print them and then you'd put them in a photo album and then you'd look at them every once in a while. But now they're just on your phone, and I guess sometimes we're going to display them on our television screens. So if you have 8 megapixels, it'll look nice on a 4K television if you have a 4K TV. We'll go with 8 or 12, it doesn't matter. But we have to know because we have to multiply this. Because we have to figure out how big the file is. So how big is a GIF? How big is a JPEG file given a particular resolution? And basically, what we're going to do is we're going to multiply our resolution times the color depth. And we have color depth. But we need to do it by bytes. Okay? So how many bits are in a byte? 8. Thank you, Patrick. 8, right? So that means if I have a GIF, I have to multiply it by 1. So actually, I don't need to do a multiplication because it's 8-bit. Now, if I have a JPEG, it's 24 bits. So that equates to how many 8s in 24? 3, right? So I have to multiply that by 3. PNGs, I have to multiply by 3. And TIFFs, I have to multiply by 6, right? So we take the resolution times 1, 3, 3, or 6. Does that make sense? And that will give us a number. Now I know that they're using 800 by 600, okay? So that gives us a number. That number is how many bytes? Yeah. So then we have to do a compression. And by the way, most cameras now use around 10 instead of 25:1 for JPEGs. They use about 10:1. So for JPEGs, use 10:1. Don't use 25:1. Use 10:1. And so the total number of bytes needed to store the image would be the resolution times, whatever the color depth is, divided by the compression ratio. So if it was a JPEG, we wouldn't use the 25, we're going to use 10. And that gives me a size for one JPEG, an average size for one JPEG at that particular resolution using that particular compression ratio, 10:1. And then we're going to assume that a gigabyte is equal to a billion bytes with zeros. So don't worry about the, a megabyte is actually 1024 and, the little numbers at the end. We're just going to round it off. And that's actually correct because if you buy an 8 gigabyte flash drive, you don't actually have 8 gigabytes of storage because there's some memory that's reserved for its own kind of internal usage. So, by the way, hard drives are the same way. All storage devices are the same way. You know, you don't get everything that's on the box, basically, that's advertised. There's a little bit less. It's somewhere between 5 and 10% most of the time that you can't use because it's just used so that the storage device can work. So basically, we have to then take how many, this number multiplied by how many gigabytes the user input is, right? And then we have to divide that by the size of a JPEG, or the size of an average GIF, or the size of an average PNG, or the size of a TIFF. And that will give us how many that we can store. By the way, there's no division for TIFFs. We don't divide it by anything because there's no compression that's done to the file. That's why you're going to get a lot less for TIFFs, okay? So go ahead and use 5:1 and 8:1 for PNGs and GIF files, but use 10:1 for JPEGs. Now, let me do this. I find it easier to do a calculation for the resolution separately. Yeah, for the resolution of the image separately. So I found it easier to create a variable for resolution and then multiply the resolution, because that's fixed, right? And so whatever it is that I have, I created, I called it resolution, but so you're going to do whatever your number is, A times B, and that'll be your resolution. And then you can just use the variable in your calculations for each one. So for GIF, you would do, how would you do that? It's a number of, it would be A times B, so resolution divided by 5. Oh, no, we have to multiply it, right? Oh no, for GIF, you don't have to multiply it, right? So the resolution is times 1, so you don't actually have to do the times 1, because 1 times 1 is 1, so R times 1 is R. But you do have to, you can divide it by 5. You have to divide it by 5, and that tells you how big one image is, and then you have to do the division. So you also have to take the input, which is the numeric value. And by the way, here are my 2 hints. When you do the division, use the truncated division to do it, because that will kill the decimal places, right? Because you can't store 45.5 images, right? There's no half. So that's 1. Then that's, by the way, when you're doing the division into 1. Marco, I said use, I don't know if you caught that, but use the resolution, not 800 by 600, but use for either 8 gigabytes, 8 megapixels or 12 megapixels. We looked it up together and I showed you what they were, but I don't know if you were here at that point. So don't do 8 by 600 is basically what I'm saying. Do that and then format your output so that it does not give you 0.0. Okay? You're welcome. Do we do all the forms? Yeah, you're going to output, we're going to do every one. So like I said, my output was here, let me run it again. my output showed me, yeah, 4x3. So here, let me run it again. Damn it, I got to open it first. Python programs. How many images is what I called it? Open with idle. There we go. Then I click run, and then I got to share it. Come on, I got to. Everything is hidden behind something else on my screen. I got to move it. Come on, grab it, move it. There we go. And you can look up 8 if you want to do 8 too. So let me share this. So I will go here, stop share, and I will go share screen. Which one is it? It's this one. There we go. So we're going to calculate each one. So the user is going to have one piece of input, and then it's going to tell you the output for each one. So you're going to have to figure out the number of JPEGs, the number of GIFs, the number of PNG files, and the number of TIFFs. And again, it's the resolution multiplied by the color depth. So what did I say it was? It's 1 for GIFs, it's 3 for JPEGs and PNG files, and it's 6 for TIFF files. And then you have to divide that by the compression ratio. And then you have to take that number and divide it into however many, not gigabytes that we have, because it's a billion times 16, so it would be 16 billion bytes, right? In this case. So you have to do a multiplication for the flash drive size and convert it into bytes. And that calculation you have to do for each of the 4 different file formats to come up with a number. And then you just print it out. And so what I want you to do is I want you to have a double space here between the user input and this line. And remember that before this, I want you to have a welcome. So tell me what the program does, and tell me how many megapixels you're calculating for. Because that's important, right? Because I'm going to get different numbers. So if you're calculating for 8, you're going to be able to fit more images than if you're calculating for 12. So that should be part of the welcome statement. So remember your 4 kind of steps. Create your welcome statement. And by the way, when you're writing code, don't forget at the top to do your name and the lab and the project, etc., and to give me a description of the project in your code. Then do the 4 steps. So create a welcome area. Give me a double space probably between the welcome area and the enter the flash drive size in gigabytes. Then do your value assignments. There's one piece of input that we're getting, and we're doing the value assignment, and then we're going to do our calculations. So the first thing that you're probably going to do is figure out the size of the flash drive, because you have to take the 8 or 16 or 4 or 32 number and multiply it by 1 billion. And then you're going to figure out how many you can store for each image on that by doing the division. And then you're going to, and multiplication. Then you're going to, and remember I said truncated is the best way because it drops the, well, I guess you don't have to do truncated, do you? We could just format the output when we're doing step 4 and displaying our results. I guess we could just format the output to 0.0f. But would that round up or down? Does it round up? Because that'll give us the wrong answer, because it'll be off by 1 if it rounds up. Does that make sense? And so if I have, I can store, 321.6 images. If it rounds up, it's going to say I can store 322, which is wrong. You can store less. You can't store more. So I'm not sure. I don't think it really matters because this is just a rough kind of estimate. It's an estimate for how many. And by the way, mine, I went to the SanDisk website and they had a chart that had 4 megapixel, 8 megapixels, 16 megapixel, 12 megapixel, 16 megapixel, etc. And it showed how much you could store on their different flash drives. Mine was within 80 JPEGs, so the program is actually working the way it's kind of supposed to. There's always going to be a difference because you can only estimate, but you can get close. So there you go. That's the program. Those are the things that you need to do. You have to figure this one out a bit, okay? So figure out the math. What I would do is I would take a piece of paper and figure out how, if you can figure out how to do one of the 4, you can figure out how to do all 4 because they basically work the same, except our values are going to be different. Does that make sense? When is it due? A week from, well, a week, next week. Next Tuesday, Thursday, I think is how we're going to do this. We're going to split it up. So you can turn it in whenever, well, yeah, let's talk about due dates. Thank you for mentioning that. Because we had a bit of a issue with it taking so much time for me to look at your programs running, and I was running over. Shit. I completely forgot to actually think about this. So, it'll be due next week. I'm going to do, because I'm sure some of you are going to be done on Tuesday and some of you will want to drag it out till Thursday. I'm gonna grade some on Tuesday to see if I can get a little bit of a jump start so it doesn't take so long on next Thursday in each lab to do. I'm used to the labs being combined, so I'm used to doing all of this stuff in, okay, so it used to be that we had lecture twice a week and everybody had one lab and it was one big chunk of time. So now we have 2 lectures and 2 labs a week, but just if they were combined, then I could get everybody out of the way, right? Because it would just work. There'd be plenty of time. So I'm still trying to get used to this new format. I'm trying to get used to the whole class. It's taking me longer to get through chapters because I didn't know how long it was going to take, because theoretically, if I read this, it shouldn't take too long, but then in order to explain stuff accurately and in detail, it takes longer. So, and since this is the first time this class is gone, right, I'm guessing we spent a little bit too much time on critical thinking, and we should have started programming a little bit earlier, but it's all kind of working itself out. So you guys are my guinea pigs, so I apologize, but that's just the way it is. You guys are my guinea pigs. But in 2 years' time, this class will be nailed down solid. No, next semester probably they'll still be a little bit guinea piggy, but next fall it'll be down. I'll have it down. So, having said that, unless you have any questions, there you go. And like I said, I'm gonna try to grade stuff. It's really strange. You would think that because we are not meeting, yes, it is due next week. I'm just not sure what exact day. But, well, it'll be due by Thursday. You have to have it before Thursday. You can turn it in on Tuesday. Or some of you can turn it in on Tuesday if you want.